Very good morning students. Myself Ashrit sir. Today we will discuss another part of your study of compound ammonia, the chemical properties of ammonium hydroxide. What is that? Ammonium hydroxide on dissociation it produces ammonium ion and hydroxyl ion. Okay. Another property is reaction with indicator. What is the changes in the common indicators when ammonium hydroxide is treated? As we have discussed earlier, when alkalis, ammonium hydroxide also changes red litmus paper to blue and it turns turmeric paper to brown and it turns colorless phenolphthalein to pink like your bases. Now we will discuss the reaction of ammonium hydroxide with acids. As ammonium hydroxide is a base, when it treated with an acid, it forms salt and water. It produces salt and water. So when ammonium hydroxide is treated, it forms ammonium salt and water. As the equation is given, ammonium hydroxide when treated with HCl, it produces ammonium chloride and water. And ammonium hydroxide when treated with nitric acid, it forms ammonium nitrate and water. And similarly, when it is treated with sulfuric acid, it forms ammonium sulfate and water. So these are all the treatment or the reaction with the normal acids or common acids. Now we will discuss the reaction with the soluble salts. What are the soluble salts we are discussing? This is all similar what we were discussed in the qualitative analysis or analytical chemistry. Okay, what is this? Suppose lead nitrate is the soluble salt. When treated with ammonium hydroxide, it forms lead hydroxide, which is the white precipitate with ammonium nitrate. Similarly, zinc nitrate is treated with ammonium hydroxide, it forms zinc hydroxide. As we discussed earlier, gelatinous white precipitate is formed with ammonium nitrate. And ferric chloride, when treated with ammonium hydroxide, it forms ferric hydroxide, which is reddish brown precipitate. And ferrous sulfate, which is green in color, changes to dirty green, forming ferrous hydroxide and ammonium sulfate. And copper sulfate, very shortly we discussed very few minutes back. Copper sulfate with ammonium hydroxide, it forms copper hydroxide and ammonium sulfate, which is bluish white precipitate in the properties of ammonia we were discussing. Now, this bluish white precipitate, when excess of ammonium hydroxide is treated, like copper sulfate and ammonium sulfate, copper hydroxide and ammonium sulfate is formed. Along with that, ammonium hydroxide is added, then it forms CuNH3 SO4, that is tetraamine copper sulfate, which is deep blue in color with water. It's the same case like in case of silver chloride also. When silver chloride treated with ammonium hydroxide, initially it forms white precipitate or silver hydroxide. Then again in excess of ammonium hydroxide, it forms diamine silver chloride. As silver hydroxide, which is soluble in ammonium hydroxide, we cannot give the first reaction. Directly it is given as 2NH4OH Ag NH3 Cl, diamine silver chloride. Similarly, as we discussed in case of zinc, it forms zinc hydroxide. So zinc chloride, it forms zinc hydroxide and ammonium chloride. So ultimately in this product also, when excess of ammonium hydroxide is added, so zinc hydroxide plus ammonium chloride with excess of ammonium hydroxide, not sodium hydroxide, ammonium hydroxide, it forms tetraamine zinc chloride, plus water. Okay, now we will discuss about the uses of ammonia. Okay, fine. So what are the uses, how ammonia is used? This ammonia gas we have prepared. Ammonia is used for the manufacturing fertilizers like ammonium sulfate, ammonium nitrate, ammonium phosphate, and urea. These are the nitrogenous fertilizers which are prepared by using ammonia. Then ammonia is also used in the manufacture of nitric acid by the process of Ostwald's process. When we will discuss the portion of nitric acid, there you will find this Ostwald process. We will discuss in detail at that time. Okay. Then liquefied ammonia or liquid ammonia is used in the as a refrigerant in the ice plants and cold storage. Okay. Now we'll discuss what is refrigerant gas and what is the suitable alternatives to overcome the problems. Okay. So what is refrigerant? A refrigerant is a substance which easily undergo a reversible phase change from a liquid to a gas. Okay. Again repeating, a refrigerant is a substance which easily undergo a reversible phase change from a liquid to a gas. Traditionally, earlier we were using chlorofluorocarbon, which is commonly called CFC, were used as refrigerant in our ice plants or the cold storages, which is an organic compound which is commonly we can name it as freon. Okay, commonly named as freon. So what is the reaction takes place due to this CFC? Okay, now the most important reaction of CFC is, the formula of CFC is CCl3F, trichlorofluorocarbon. Okay, trichlorofluorocarbon, which dissociates to give CCl2F dot and Cl2 dot. What is this Cl dot? Cl dot is a chlorine atom that behaves differently than Cl2 or chlorine molecule. What happens? This chlorine atom, when comes in contact with ozone or treated or reacts with ozone molecule, it forms ClO plus oxygen, O2. So what happens? Ozone absorbs ultraviolet rays better than oxygen. So ultimately, when ozone is depleted due to this chlorine atom, so the depletion allows more ultraviolet rays to the earth. Okay. So what are the possible alternatives? Because we are facing so many problems, the depletion of ozone layer, and due to which the ultraviolet rays, infrared rays are entering through those cracks of ozone layer and reaches to the earth surface, which is causing various problems. Okay, so the possible alternatives to overcome this CFC is hydrochlorofluorocarbon. What is this hydrochlorofluorocarbon? CF3 CHCl2. As Cl2 is there as compared to CFC where Cl3 were there, so its breakdown releases a lower percentage of chlorine, causing lower ozone depletion. So another alternative is hydrofluorocarbon, HFC. It has no chlorine, understood, and thus it is ozone safe. Another alternative is butane or propane, which are the hydrocarbons which is ozone safe as they do not contain any chlorine, and it is also cheap, but the problem is it is flammable and poisonous. Another alternative is water and steam. So these are the alternatives which we can use instead of chlorofluorocarbon. So children, this is all about your study of compound ammonia. We discussed all details. Now we will discuss in our next class other study of compound nitric acid. Okay, thank you children.